This online lesson is about atoms, about the structure, the particles in them, and the difference between elements, ions, and isotopes. After this lesson, you should be able to describe the difference between different ions, different isotopes, and different elements. Alright, so first let's just talk about the three particles that are in atoms. There's a positive particle. We'll use blue to represent them, and they're called protons. And they are positively charged, and they are found in the nucleus, which is, if you think of an atom, atoms are mostly empty space. So here's an atom, it's mostly empty space. Oops, went off the side there. But then there's this really tiny, extremely dense part in the center of it. It's called the nucleus. So protons are positively charged particles that you find in the nucleus. The next one we're going to talk about are neutrons, and we're going to use gray for them. So gray neutrons. Neutrons are neutral; they have no charge, and they are also found in the nucleus. So they are snuggling up with, and in fact, they're helping all of those positively charged protons kind of stay together in such a small space in there in the center of the atom. And then the final particle we're going to talk about are electrons. Can you see that little tiny electron? I made it a lot smaller on purpose because electrons are a lot smaller than protons or neutrons. Electrons are negatively charged, and they're found in the part of the atom that's called the electron cloud. So the electron cloud is all of this mostly empty space that the atom consists of. And in the very, very center of the electron cloud, that's where you'll find the nucleus. So most of the atom is empty space, and I guess you'd call it the electron cloud. And in the very center of that, you have this really dense part that has the protons and the neutrons, called the nucleus. Along with these charges, the different elements or the different subatomic particles have different masses. A proton's mass is 1 AMU, which stands for atomic mass unit. Neutron's mass is 1 AMU. And then the electron's mass is 0. Because electrons are so very, very small, they do technically have mass, but they're so very small, it's negligible. Basically, we can ignore it. So later in the course, when we start talking about the mass of atoms, what you can see is that almost all of the mass in an atom comes from the particles in the nucleus, whereas almost all the space or volume of an atom comes from the electron cloud surrounding the nucleus. Kind of neat. Alright, so how does this work? Well, if you look on the periodic table of the elements, you can see that there are different types of atoms, and the different types are called elements. And so you might be asking yourself, well, what makes a hydrogen atom any different from a helium atom, or sodium any different from aluminum, or hydrogen, or chlorine for that matter? Well, the answer to that question is actually quite simple, and it has to do with one of these three subatomic particles, and the one is protons. So it's the number of protons in the nucleus of an atom that actually gives it its identity as an element. So if I were to draw a hydrogen atom, I would draw basically one proton, and there may or may not be one neutron with it, snuggled up with it, and there may or may not be one electron, zipping around somewhere outside it. And if you think of this space, like a three-dimensional sphere space, where the electron kind of zips around the proton, then that's a pretty good model for a hydrogen atom. So what makes that hydrogen is the fact that there's one proton. There's only one proton. So I could actually draw, if I wanted to, I could just draw one proton with one electron zipping around it. Somewhere around it. It's right there. And since there's just one proton, it's still hydrogen. So this one is hydrogen, and this one is hydrogen. And the reason for that is because the number of protons is the same. It's the number of protons that determines the element that the atom is. It determines its properties and how it behaves and things like that. So the next element down in the periodic table is helium, and helium has 2 protons. So if I were to draw 2 protons, let me throw 2 neutrons in there. So there's our nucleus, right? Nucleus in the center. So here's our electron cloud in helium. We're going to say there's 2 electrons zipping around in that electron cloud. There they are, just zipping around in there somewhere. And that, if you look in the nucleus of this one, there are two protons, and that's what makes this helium, not hydrogen. So it's the number of protons in the nucleus that determines what element an atom is. So if I wanted to, you know, I could keep doing this with lithium and beryllium, you know, all the way up to things like mercury and plutonium and things that have crazy numbers of protons. You know, borium has 107 protons. But that's what determines which element an atom is. It's how many protons are in the nucleus. And just one more time to enforce the vocabulary, because these atoms have the same number of protons, they are the same element, and that element is hydrogen. And because these 2 atoms have different numbers of protons, then they are atoms of a different element. They are different elements. This atom is a hydrogen atom, and this atom is a helium atom. So the number of protons in an atom is really, really important. It's so important that we sort the elements by that number on the periodic table. So this number that I drew in here, as I was counting up the protons, it actually has a name, and we refer to it often in chemistry. It's called the atomic number. And the atomic number basically is just the number of protons in that element. We use this number to sort the elements on the periodic table, and we use this number to identify which element we're actually talking about. So that's a pretty good introduction, and I think I'm going to stop part 1 of this video lesson here. The really important point to take away from this is that it's the number of protons that determines which element an atom is. So join me here after the break, and we'll look at part 2.